So number 3 in problem set 3 is asking us to identify whether or not each of these molecules are constitutional isomers. And what that means is whether they have the same molecular formula and different connectivity. So starting off, we have a cyclopentene with 2 methyl groups right next to each other, and then 2 methyl groups separated by a carbon. Now there are still 2 methyl groups in a cyclopentene, so these are constitutional isomers. For the second one, what we're looking at is actually a rotated, we have to think about this in terms of numbering carbons, so we're going to start on this one over here on the right and follow the longest chain, 3, 4, 5, and 6. And then over here, we're going to start right at the top here, 1, 2, follow the longest chain, 3, 4, 5, 6. So we have the same formula for each of them. We've got 6 carbons in the main chain. We've got a methyl group, another, and another. So 1, 2, 3 methyl groups, 1, 2, 3 methyl groups. So it is the same molecular formula. But if we look at which carbons these methyl groups are on, carbon 3, carbon 3, carbon 4, and carbon 5, these are identical molecules and are not constitutional isomers. So for the third one, these are different molecular formulas because this has a double bond. So just right off the bat, these are not constitutional isomers. For D over here, we can see that these have this is that. Let's number the chain starting over here, 1, 2, 3, 4, and 5. And then on this one, the same thing, 1, 2, 3, 4, 5. So we can see a double bond on carbon 2 and a methyl coming out of 3. This is, again, the same formula, so this is not going to be a constitutional isomer. So for E, again, this is meant to be here. These are going to be the same molecular formula, and we can see that because there are no extra carbons or anything. The only difference is this double bond right here. But we're gonna number these carbons. So I'm gonna start here, work up this way, 3, work around the hex, and 6. And then on this one, I'm gonna start down here, 1, 2, 3, 4, 5, and 6. So what we can see is that the way we numbered this these chains is with this group here coming off of carbon 3, and so these are actually the same connectivity and again are not constitutional isomers. And then down here we have a similar problem. So let's go ahead and do the same thing and number the carbons. And again, I'm going to start right here, 2, 3, 4, 5, and 6. And then on this one, I'm going to start here, 2, 3, 4, 5, and 6. So what we can see is that this is a different bonding pattern because this little side chain substituent is coming out of a different carbon. So this is not the same, but it is the same molecular formula with a different connectivity, and that is a constitutional isomer.